So I wanted to talk about problem number 4 because I saw some struggling there. So this question is asking us to find the shapes that have 2 or more pairs of parallel lines. So what that's asking us is it has 2 pairs of lines that are parallel. Remember, parallel looks like this. It means that they're going to stay the same distance apart and they're never going to cross each other. So they're going to stay the same distance, they're never going to cross each other. And 2 pairs doesn't mean 2 lines that are parallel. It means I have 2 parallel lines here, that's one pair, and then another pair of parallel lines. So I'm looking for the shape that has at least 2 pairs. So when I go through here, I need to look at each of the lines. I need to look at how they intersect with each other. So if I look at A, I can see that I have a line here and there's no line that is running parallel to it. That means it's going in the same direction up and down and it's not slanted towards it. It's going to stay the same distance apart from it. I don't see a line that's parallel to that, so I know that A doesn't have any parallel lines. If I look at B, I can see that I have one set of lines here, a line up here, and then if I look at the opposite end, there's another line that is running the exact same direction, and if it were to continue out this way, it would never cross that shape or that line. It would stay parallel. So I have one pair. Let's see if I can find another pair. Let's look at this line over here. I go across, same thing. It's exactly the same. It's going to stay the same distance apart. Even if it kept going and going and going, it would never cross that line. So B has at least 2 pairs. You might even be able to find more pairs of parallel lines if you look at that shape. Let's look at C. So C is a square, so if I look at this line down here, I look across, that's another line that is also parallel to this one because it's going to keep going and never touch. Look over here, this line on this side, okay, go across, running up and down. If it kept going and going and going, it would never cross. So there's one pair here and another pair here, so that's 2 pairs. Okay, D, this is a little bit more complicated because we have lots of lines and they're all slanted in different ways, and we need to see, are any of these lines parallel? The best way to see is look across, because usually the parallel line is going to be across from it. So if you look at this line over here, the line across from it is over here. Now, these are a distance apart, and if you look at first, you might think like, oh, they're running in the same direction. But if you could imagine this line just kept going, and imagine this line just kept going, they're going to start to get closer and closer together the longer they go, and eventually they're going to cross. So those lines aren't parallel. And if I look at each line and I look at the line across from it, there's no line that is going to keep going forever and not touch the line across from it. So D has no parallel lines. Let's look at E. So if I look at E, I have one big line down here, my trapezoid, and then I look at the top, and that line is flat, and if it were to keep going and going and going and going and going, it's never going to cross this line down here. So it has one pair of parallel lines, but I need to have 2. The other lines, if I look, they're slanted towards each other. So if they kept going, they would eventually touch, meaning that those are not parallel lines. So E only has 1 pair, and I'm looking for shapes that have 2, so it can't be E. Let's look at F. Now this one is a little tricky because you might look at it and think it's not a square rectangle, so it doesn't have parallel lines. But let's look. Remember, you have to look across. So look at this top line up here. Look down here. That line, if it kept going and going, is never going to touch this line if that one kept going and going. So that's parallel. Now let's look over here. Okay, this line here. Let's look across. Same thing. That line's never going to touch this one. It's going to keep going so the exact same distance apart. So that's a parallel. Now this one. Look across. If it kept going and going and going, it's never going to touch, so that is also a parallel line. So F actually has 3 pairs of parallel lines, and we only need 2, so F definitely works. And now finally, let's look at G. G's a kind of like wonky shape. We don't really see this shape places. Let's look at it. I have this line here, and look across. You might think that it's parallel, but if you look, it's actually slanted slightly away from it, meaning as they keep going this way, they're going to get farther and farther apart from each other. Remember, parallel lines have to stay the same distance apart, so it can't be G. Same thing here. This line over here and this line up here is slanted differently, And these two are definitely going to touch if they keep going. So G has no parallel lines. So what you should have gotten for number 4 is B, C, and